133.4.
Correct. So do the entire right, and then do the practice 1 through 3, not 4. Okay, so let's look at these problems from the bell ringer. Hopefully they shouldn't take us too long. Do we really only have 9? No Jeremiah, so that'd be 10, 11. No. Why don't we have 9 people? 2, 5, 7, 9. Okay. 11. 13. We still have 16 people in here. Who else are we missing? Grayson, Jelani,
Jada, Caitlin.
Jada.
I think Caitlin
Caitlin.
will online.
Okay. So that's so Max at 15, but we are still missing Jada as well. That's who I was missing. Huh? I think when we say online, I mean going to homeschool. You don't really have an option to go online.
Yeah, like I was
Like
in
withdrawing
homeschool,
from
like,
Hillcrest.
but still be enrolled in Hillcrest, and we had to do it before like school started. We had to go to like these meetings in the summer.
All right. So I'm going to open this in the review workspace. Let's talk. All right. So we had a lot of similar options here from what I saw talking about, anyways. Okay. So I will say partially correct. But what did we need to identify?
Numbers.
So M and B, right? So I need y'all to identify the slope in the y-intercept page, Jeremiah. Go ahead and log into your computer, or grab a computer, get logged in. Come on, you gotta get going. So for the most part, what is everyone agreeing that the y-intercept is? Listen to my question again. The y-intercept.
7.
Dang it, DJ, I was just listening to you.
-7, I believe.
I'm backing you up.
So, okay, so if we look, and so be careful, because I did see someone say 8 or -8. Be careful and count, right? So this -8.43 is right here, so that'd be -8, and that'd be -7. It's easier to count from the top down, so -1, 2, 3, 4, 5, 6, 7, right? So, how do we always identify the y-intercept? There's 2 ways.
I count and see where it hits the corner of the squares.
Okay.
1, 2, 3.
But how do we know where to look for the y-intercept?
Just start at your thing.
On the y-axis, and we always know what about the x value, KJ? KJ? Come on, this is fundamental. You got to know something about the x value every time for a y-intercept.
Slope? I don't know.
The x value is slope? KJ, what should we know about the x value of the y-intercept? We looked at the y-intercept yesterday with the parabolas. If you don't know this, you better pay attention to this because this is fundamental. We talked about it for over a week now. And you learned it in Algebra 1. Jaden, do you remember what we should always know about the y-intercept? Oh my gosh.
Did I get it right with that?
What did you say?
I said that one of the points has to be 0, it has to be 0.
So what do we know about the x value?
Always has to be 0.
The x always has to be 0. KJ, what do we know about the y-intercept?
Wait,
Fam, she just said it!
but you said the x.
Yeah, or sorry, the y-intercept. What do we know about the x value? That, you're right, my bad.
It has to be 0.
The x value has to be 0. Jaden, what do we know about the x value and the y-intercept? It has to be 0. Is it ever going to change? No. Every point on the y-axis, what is the x value? 0. Okay, so we all agreed that our y-intercept was 0, -7, or for the most part. For the person who said 8, hopefully we understand -7.
That was me.
Okay.
I understand it's negative, I just didn't put negative.
And then miscounted maybe? Yeah, so be careful about that. So then I see several different slopes. Now, I do want to point out you need to be careful here. My guess is someone accidentally hit multiplication instead of addition, but we want the slope to be multiplied by x, right? So not -7 times x, maybe -2 times x, but I see a +2, see a +1, I see a 3/2 through here. So how are we going to identify our slope? There's 2 different ways to identify the slope.
The slope.
I count.
So rise and run. Now that we need to be careful with that because it can be hard sometimes. to identify the rise and the run, but you want to look for clear points. Notice I can't go here, maybe I could, but is that a clear point on one of the grids? No. Tell me when to stop when I get to a clear point.
Stop.
Stop.
Right here?
Yeah.
A little bit higher?
I can't see.
no.
Right there.
I can't see.
You're good.
Stop.
So it doesn't matter where we go, how far am I going up? 3 to the right.
2.
Notice you can even do it from here, and I could go all the way down to here. How far did I go down? 6. And how far did I go to the left?
4.
4. Notice if I take -6 and I divide it by -4, what does that simplify to? 3 divided by 2. Just try to break that, so that habit, okay? So 3/2 or 3 divided by 2. And so there we have it. Our slope is 3/2. And so you can write that slope however you want, or not however you want. You can either do the -7 plus 3/2 x, or the y equals 3/2 x minus 7. Now, I will point out, if you are having a hard time finding that rise and run because of those points, yes ma'am?
Oh, I had a question. So that's how you do it if it ain't like on the.
If it's not on the table, I was about to look at a table, is that what you were about to ask? Yeah. So don't forget, that's how we look at, so it's the rise and the run if it's on the graph. But we can make a table, and we just have to be careful about making that table. 0, -7. This point is 2, -4. This point is 4, -1. And so we want to notice in the y, we're adding 3, correct? Okay, so that's my change in y. How much am I changing in the x? 2. So we need to be careful and recognize, is it always changing by 1 in the x direction? No. And so, once again, if I do the change in y divided by change in x, don't I get 3/2 again? Does that make sense, LaShannon? What doesn't make sense?
When you doing the 0 to 2.
Well, remember slope, one way to talk about it is rise divided by run. Well, if I'm talking about how much it rises by, you must be right outside your mind.
Is you
I'm
getting
gonna
that
fail. I'm gonna fail anatomy. Homework grades are the only, like, I'm listening, I'm just like, I just gotta cut this out.
I need to do that at home then. But remember, if I'm talking about the rise, that's how much the y is changing by. And if I'm talking about the run, that's how much the x is changing by. So, the change in y divided by the change in x. So, to go from -7 to -4, I'm adding 3. To go from -4 to -1, I'm adding 3. But that's only my rise, my change in y. I still need to look at the change in x, +2, +2. Right? Because I just grabbed those points from the table, or from the graph. So, the change in y becomes 3, the change in x is 2. Slope is 3/2. Does that help clarify? Yeah. And so don't forget, on the quiz yesterday, or the understanding check, could you have taken your graph and made a table to identify your change in y and change in x? Yeah. So you can always do that. Alright. Hopefully we'll move quickly through these. Vertex form, a times x minus h squared plus k. Be careful just in typing it in. Whoever did this one, notice that k is where?
The top of the two.
That's in the exponent, right? So we don't want it in the exponent, so just be careful. Whoever did this one, we accidentally added an extra parenthesis, and I know that's just typing into the calculator, but overall we're pretty good there. Alright, we good on vertex form?
Yeah, I don't like know it by heart, but like, you know.
Okay, so what should we do if we don't know it by heart? Study it, right? Like, look at it a couple times a day, that's all you gotta do. Make sure you know that vertex form. The more you work with it, the better you'll become comfortable with it, but just look at it, right? The more you look at it, the more you write it. And I will say that is one thing. When you study, don't just look at something, write it down. The more you write it, there is a connection between your hand and your brain, and the more you write it, the better you'll remember it. So write that equation. And in fact, if I were you, if I were trying to write the vertex form of some function, which we'll start doing that soon, I would write down this equation every single time. this generalized equation so I know what to substitute in. It's gonna help you remember it way better.
I know, that's my problem, just remembering that in the first place, because like none of it means anything to me, it's just like random letters, and it just,
Well, hopefully it starts to mean something. What does the A represent? Or what is the A telling us about?
The vertex.
The A?
The A is the
Concavity, right? And we'll learn more about how to find that A moving forward, but that's known as, it is a vertical dilation, but it's also defining our concavity. That's the big thing. And what are H and K defining?
of
The point.
the same, yeah, the sides of the thingy. What's the parabola? I don't know the like words, that just doesn't,
Then maybe we should go look at our Desmos because it's in there. What do H and K represent?
The points.
What points? Thank you. It's vertex form, right? We need to know that. H, x equals h, that's our axis symmetry. So there is meaning to these, but you do have to write it down a few times. So look at your notes the first few times. Write down the generalized equation and then go into substituting those values in. And then ax squared plus bx plus c. Honestly, it's alphabetical. Follow that. Be careful, it's not a 2, it is just an a in general. But it's ax squared plus bx plus c. Please hear me very clearly on this. I will never ask you to write standard form. Okay? But you have to recognize standard form because that's going to tell you your A, your B, and your C are important. And we'll learn about how to use that to get other forms. And you need to know that A is again defining the what?
Concavity.
Concavity. A is constantly defining our concavity. What is defining the y-intercept? The C. And KJ, what do we know about the y-intercept every time?
The Y or the X?
The y-intercept. What do we know about the y-intercept every single time? Not sure? Jaden, do you remember what we know about the y-intercept every single time?
It's always on the line.
It is always on the y-axis, so we know one of those values. We either know the x or we know the y every single time. Which one do we know? The x is equal to 0, right? Yes, it's the y-intercept, so we know x is equal to 0 every time. So 0 comma c is our generalized y-intercept. Finally, factored form. A bunch of us did not get here, and that's unfortunate. It was tough to get the subscript, so I didn't stress about it, but a times x minus r1 times x minus r2. This is the one we haven't explored very much. I think we briefly touched on it once again. What is that a going to define?
Concavity.
Concavity, right? If it's negative, that it's going to be concave. Down. If it's positive, it's concave. Up. So we still need, and also don't forget, if it's between -1 and 1, is it going to be wider or narrower?
Narrow. Well,
Wait, you said -1?
That can
If it's between -1 and 1, it's going to be wider. We'll look at it in a second. And if it's greater than 1 or greater than -1, it's going to be skinnier, narrower, okay? We'll talk more about why that is, and it's not actually because it's wider or narrower, but that's what you see, so that's what we're going with. And we still need to explore what we mean by R1 and R2. So, all that being said, we should be logged into our computers. Nope, that's not the right spot. Oh, before we get to the computers actually, I want to look at this. I believe that I quickly showed you this yesterday, but I want to make sure it's clear. Right? So, here is the graphic organizer pages M1-73 and through M1-75. This one specifically is M1-74 that you are doing for homework. These are due on Friday. What I am asking you to do, right, is, and honestly, you can kind of skip the graphs and their functions. What I really want you to focus on is down here, right, determining those key characteristics. When we looked at that standard form, was it easy to identify, or did I ever ask you to identify the axis of symmetry? No? So what are you going to have to use to identify the axis of symmetry if it's in standard form.
This website.
Or just in general, a
Graph.
graph, right? And so that's something to recognize and to write a note about. Hey, if I'm looking for axis of symmetry in standard form, I'm going to have to graph it, right?
Yes.
However, if I were to ask you about concavity based on standard form, is there something that you automatically know just based on the equation? The A, right? If A is positive, it's concave up, right? So that's what I'm asking you to do. So the things that you can't identify from the equation, just indicate, hey, I'm going to have to look at a graph. But the things that you can immediately recognize from that equation, write down how you're going to recognize those things. Right? So we already know we can look to see concavity. What's the other feature of the quadratic function that we can see in standard form? The y-intercept, right? And make sure you write it the way we did in Desmos, the correct y-intercept. Okay? So, from there, I need to pull up Desmos. Don't forget, you can automatically log back into Desmos if you go to student homepage, click on that link. So click on the link to go to student homepage, and then sign in, right? This is how you can log in whenever you want. Right, so log in, yeah, sign in with Desmos. You can log into your notes whenever you want so that you can study for understanding checks, which we will probably have one on this information on Friday. You can log in here to help you with the homework, right? You gotta make sure you understand this. Now, we should be, yeah, I was gonna say, we should be somewhere around here on 14. Oops, I'm stood view. Where so make sure you make the notes about adjusting the value of A. That's where you're going to go to slide 15. But we should be picking up here in slide 16 to identify what happens. Man, slide 16 should not say A. It should say R1 and R2. I'll have to fix that in the future. So adjust the value of R1 and R2 in factored form and observe what happens, right? And so you're going to make those notes on 17. Alright, so work with your group to figure out what R1 and R2 are defining. Couple of quick things. We should finish up this activity, or finish up slide 18. Slide 19, you don't have to do. I decided to use the graphic organizer from the textbook, so don't do slide 19, and you'll finish up with slide 20. Okay? If you get done early, then you can actually start working on your graphic organizer in class. And then once everyone's done, we'll get to work on the next activity. Any questions? Ready to get to work? And go!